Hello everyone and welcome to this video of the course Robotics. And in this video we are going to discuss about robotics actuators, sensors and robotic batteries. The content covered in this video includes introduction to robotic actuators and the type of robotic actuators being used in industry, robotic sensors and the type of sensors that we are going to use for self-driving car use cases and some sensors that we are going to use for our demo purpose. We'll be also discussing about the batteries to be used in robotics and various types of batteries being used. So let's get started with that. So discussing about the subsystem in robotic control, we have already seen this kind of robotic control system in the previous video. We know that in robotic control system we have a controller, we have actuator, sensors and the process. That's model of robot. So if anything is fed as an input value, let's say X is fed as an input value to the controller gives it to motor, and with the axle of motor a robotic system or a process or a model is attached. So this system can be process, or else it can also be a robotic model. And there's an output encoder that's called a sensor. The sensor senses the actual output produced on the axle or on the robot or the process or the model, and it gives the feedback of the actual output to the controller. And the controller also analyzes the output produced and the actual output, or you can say the desired output and the actual output, and based on that it controls the input to generate desired output equals to actual output. So this is the basic idea of a robotic control system, and in this system this part is called the motor, which is generating some output, is called actuator, and the part which is sensing some data after actuator is called sensors. So we're going to look after actuators and sensors in this video. So throughout this video we're going to talk about the different type of actuators and different types of sensors, and we'll be roaming around the actuator sensors, and at the end we'll be also talking about and discussing about the batteries used in robotics as well. So let's get started with that, and the first topic that we're going to discuss is actuators in robotics. The meaning of actuator is something, a device or a machine that generates some motion or that generates some output in the robotic system. In actual way, it can be defined as an actuator is something that converts any electrical energy into motion, or you can say any energy into motion. It could be electrical, it could be pneumatic, it can be hydraulic as well. So an actuator is a device which converts any energy, electrical energy, hydraulic energy or pneumatic energy into motion. Actuators are the part of a robot that actually makes them move, or you can say that actually creates motion, that actually creates the output or the movement of the robot. The type of movement or the type of output can be different. The actuators can produce the linear output, they can also produce a rotary motion or an oscillatory motion as well. That depends on the type of actuator we are using in the particular robotic system. Talking about type of actuators, we have some basic types of actuators. One of them is electrical. In electrical actuators, we talk about some motors or some machines which uses electrical energy and converts the electrical energy to some motion, or you can say movement. So type of electrical motors stands from DC motors, servo motors, stepper motors, brushless motors as well. Another is pneumatic. In pneumatic, we use air pressure to generate some movement in the end device using some valves or using some pumps as well. And another is hydraulic. In hydraulic, we use fluid pressure, or you can say liquid pressure, to generate some movement. So it could be a linear actuator or non-linear actuator as well. And the last one is advanced actuator, in which we use ultrasonic motors, artificial muscles or molecular motors as well to generate some movement. So these are some basic type of actuators. In our case, we are going to broadly discuss about only electrical actuators, because in our case we are going to use electrical actuators in our robot. Talking about electrical actuators which generate some rotational and linear movement, or you can also call those electrical actuators which are rotational and linear actuators, can be, the first one can be DC gearless motor. That's a very basic form of motor which converts simple electrical energy to a simple rotational motion. That's called DC gearless motor. And the another one is DC geared motor. When you use a gear assembly over a DC gearless motor, that's DC geared motor. And we also use brushless motor for some applications like UAV or quadcopters. Stepper motors are also used when we talk about some fixed angular rotation and kind of pretty torque we need. For example, some applications of 3D printers use stepper motors. Servo motors are used in robotic arms to provide accurate torque and to provide exact rotation in terms of degree angle. DC linear actuators are used in order to provide linear movement, or you can say linear displacement, using the actuator in the robotic system. And solenoid, electrical solenoid, are used to open and close the valve or to allow or stop a particular system to process or the flow of any physical object, or that can be controlled by using solenoids. So the first one that we are going to discuss about is the DC gearless motors. DC gearless motors do have moderately high speed, high RPM. Along with high RPM, the torque the motor can attain is very low. It is observed that DC gearless motor do have very less torque. DC gearless motors can be used for low power applications, like using some motors into the boat or water boat, like that. Some applications could be some propellers in the small boats or in beam modes and other solar boats. The application in which the requirement, or you can say the criteria, is not the high torque, the criteria is only high speed in terms of RPM. The next one that we are going to use throughout the course is DC geared motors. DC geared motors are just extension of DC gearless motor with a gearbox. Because of the presence of gearbox, the speed decreases relatively compared to the DC gearless motors, but at the same time, the motor gives a better torque, a significant better torque compared to DC gearless motors. So DC geared motors can be used in some applications or some cases wherein the requirement is the torque, the requirement is the high torque. For example, some applications like robotic systems or robotic arm, robotic leg movement, like that. We generally consider the application or use of DC geared motors, whereas the speed is not the better concern, the torque is the main concern. Next is the brushless motors. Brushless motors are very high speed motors which do not have brushes like DC geared and gearless motors, and because of that they can provide very much high speed, but again with the high speed the torque decreases. Very low torque are provided by brushless motors. The general applications of the DC brushless motors are into propellers, in UAV, aerial vehicles, or also into RC controlled boats, quadcopters, tricopters as well. Generally, DC brushless motors requires a very good power source like LiPo batteries. They cannot run on a small power source, or you can say on a less efficient power source generally. Next, we are going to discuss about the stepper motors. So stepper motors provide pretty good torque compared to DC geared and gearless and brushless motors, and the speed in this stepper motor is variable. It is used where precise rotation is required with a particular variable speed. For example, some cases like using stepper motors into 3D printer applications and designing 3D printers. To operate a stepper motor, you need to have a special circuit to make it work. And generally, stepper motors are used with microcontrollers to program their working, or stepper motor drivers to make it work in a special manner. Next is the servo motors. Servo motors provide comparatively very high torque, very good torque. It rotates a maximum of 180 degree. In some cases, it also does a rotation of 360 degrees as well. It rotates to a particular position depending upon the duty cycle of the PWM. So servo motors could be relatively used in the applications where you want some exact angle of rotation. For example, robotic arms, end effectors, picking and placing objects. Another is DC linear actuators. Linear actuators are used in some applications wherein we require linear movement. So they provide linear movement, and they're made of a DC motor connected to a lead screw, which generally gives a linear movement. So they are almost similar to DC motors, and hence speed can be controlled using PWM in DC linear actuators. And the last one is solenoid, electrical solenoids. They can be electromechanical, hydraulic, and pneumatic driven. Most of the solenoids are electromechanical and hydraulic. The stroke is usually very small, but they are pretty fast in operation and can be made to work using a simple MOSFET or transistor. And the most of application of solenoid is found wherein we want to close or open the valve or control the valve, control the flow of liquid, air, and control the flow of physical quantities. So the main question is choosing an actuator, which actuators to choose in what cases. So that depends on a couple of questions. One of the questions could be, is the actuator being used to move a wheeled robot or not? If it is being used to move a wheeled robot, the appropriate one could be DC geared motors. The second is the motor being used to lift or turn the heavy weight? If it is being used to lift or turn the heavy weight, the appropriate type of motor could be servo motors. Is the range of motion limited to 180 degree and need to good torque? Again, servo motors could be used in these cases. Or does the angle need to be very precise? If it is like that, you can use stepper motors as well over here. Is the motion straight line? Linear actuators could be used. So these are a couple of questions and criteria which can help us to choose which actuator to use in what use cases of a robot or robotic system. Now next question is how to drive these motors. Let us say that we want to drive a simple DC motor using a microcontroller pin. Then that can be made possible using a simple transistor circuit like this. So in this case, here we have the microcontroller unit, and from there we have one port, that is port B, let's say #1, and the signal provided by port B1 will be fed via an resistor to an base of NPN transistor, and as soon as the positive signal is coming up, by default it will make it forward bias and it will generate a collector current over here. It will generate a current over here on the motor side, a negative current, and which will consequently drive the motors on 5-volt signal. So in this case, the direction of motor can be easily controlled using this particular setup. But in general case, we do not use this setup. In general case, we can use HB circuit, which is combination of this one. Now, HB circuit has kind of 4 switches out here: S1, S2, S3, S4 for a single motor planted in between. And in above part we have positive, and here we have negative, that's motor ground. So let's say in first case, if we switch the switch S1 and S4 close, so that will drive the motor plus signal from here to this terminal of motor and minus signal from here to this terminal of motor. And when we apply plus and minus, motor will start rotating in one direction. In case we want to change the direction, possibly this direction would be a clockwise direction. In case we want to change the direction, instead of S1 and S4, we can close S3 and S2. So in that case, plus will be provided from this terminal and the negative will be provided from this terminal. So here the polarity is different. Polarity is being changed just by controlling the switch. Polarity is being changed, and that will rotate motor in another direction, that is anti-clockwise direction. So an H bridge can be easily used to control the direction of motor. And similarly, if you want to stop the motor, we can switch S1 and S2, so that will switch connect the plus and minus altogether on a single terminal, which will switch off the motor. So a dual H bridge could be easily used to control two motors, and we are also going to use a dual H bridge IC to control two motors, and that is L293D. L293D is a dual H bridge motor driver integrated circuit, dual H bridge IC. It is also referred as motor driver IC or sometimes H bridge IC as well. Motor drivers act as the current amplifier since they take a low current control signals and provide a higher current signals. So in some cases, let us say the microcontroller is generating the signal up to 3.3 or 5 volt, and in some cases we wish to drive our motors up to 12 volt or 9 volt, we can use L293D as well, which bridges the lower current signals to higher current signals to drive the motors on higher current, where the control signals fed are the low level current signals. So generally L293D motor drivers take a low current control signals and provide a higher current control signals, which higher current control signal is used to drive the motors. Talking about the simple pin configuration of L293D, you will find that from every side of L293D, this is the side number first and this is second. So from every side of L293D, one motor can be driven, and the voltage, the operational voltage of input signals can be fed over here, pin number 8, and pin number 5 are the grounds. These generally all pins are ground, so this can be fed to ground. These two are also ground. The positive power supply could be fed over here, that's the 5 volt power supply, and the power supply on which we used to run the motor can be fed over here. This could be 12 volt or any other power supply. The motor 1 could be connected over here on this side of the L293D. And the signals to control this motor can be fed on these two pins. Similarly, another motor can be connected on this side. And the signals to control that motor could be fed over here. To activate this side of circuitry, you need to give positive on this enabling pin and positive on this enabling pin to enable this side of circuit. So this is a basic idea of L293D and how to use it. This is the L293D motor driver that is we are going to use throughout this course. Now, use of L293D and motors into the robotic system could be in this way. In case, let us say, the two wheels controlled by L293D are moving in the forward direction or in the same direction with the same speed, the navigation of robot will be forward. In case both the wheels are moving in opposite direction, the backward direction with the same speed, the navigation will be reverse. In case, let us say, one wheel is moving anti-clockwise, one is moving clockwise, so it can take a counterclockwise direction. And even in forward case, if one motor is having slow speed and one is having higher speed controlled by the PWM, it can take a turn as well. In another case, if one motor is moving, let's say left is moving clockwise and right is moving anti-clockwise, so it can take a clockwise rotation as well. So by just changing the direction of motors and synchronizing the direction of motors, we can make a robot move forward, left, right and back. Next topic we are going to discuss is the sensors in robotics. We already know the sensors are some transducers which generally convert one form of energy to another form, or you can say the non-electrical form of energy to an electrical form just by sensing the physical environment. It could be sensing the temperature in the physical environment and converting into electrical signal. It could be sensing the light presence or the change in light and converting into the electrical signals. Sensors generally measure a physical quantity and convert it into a usable signal for your robot. When you are designing your robot, it is very important to choose the correct sensors to enable it to be aware of its environment and perform the task required. For example, in case of self-driving car, we need to attach some sensors which can help the robot to understand the environment, to understand the number of vehicles or the distance of vehicles on the street, to understand the signals in the street, to understand the pedestrians moving on the street, and to understand the exact location of the robot. So it is very important for a robot to have some sensors which can give it information about the environment so that it can take better rational decisions. There are generally two types of sensors. One of them is internal sensors, another is external sensors. Internal sensors are the sensors which are there into the system itself, and they are required for basic working of the system. Some of the examples of internal systems sensors could be position sensors, velocity sensors, and acceleration sensors. Another type of sensors are external sensors, which are also called as environmental sensors, which take data from environment. They interact with the environment. The examples could be vision, cameras taking computer vision, or you can say taking data from the real-time environment. The force sensor, the proximity sensor, pressure sensor, touch sensors, distance measurement sensor, proximity sensors as well. There are various sensors lying into two use cases, like infrared LEDs used for IR proximity sensors, photodiodes and phototransistors, photointerrupters, photoreflectors, photoresistors like LDRs, IR receiver modules like infrared transistors, phototransistors, photodiodes, light sensors, Hall sensors in case digital Hall sensors, analog Hall sensors, programmable Hall sensors. We also use sometimes magnetoresistive sensors, vibration sensors, air pressure check sensors, thermistors to measure the temperature, thick film thermistors, thermopiles, ultrasonic sensors to measure the distance, and we also use piezoelectric sensors as well. And next thing that we are going to discuss is the batteries in robotics. So various types of batteries we use, like alkaline batteries, lead acid batteries, lithium polymer batteries, nickel cadmium or nickel metal hydride, or lithium polymer batteries as well. How to select a battery? That depends on the current rating of the battery, the load that is required for the system to use that battery, the weight of the battery, the voltage operational, and the life cycle, or you can say the durability of the battery as well. And the last point would be the cost of battery as well. So the basic batteries used are the alkaline batteries that are most common, easiest to get, and cheapest to get as well. But they have low power capacities and very short life. They cannot be recharged, unlike other batteries. Another is we get Ni-MH and Ni-Cad, that is nickel cadmium and nickel metal hydride batteries. So these batteries are good for small or to medium size range robots. They have memory effect problem in the sense, if you do not discharge the battery completely and you try to recharge it, it might not get that. So to prevent the memory effect, whenever you wish to recharge your nickel cadmium battery, you must fully discharge it first. Nickel metal hydride batteries can last many more cycles than the typical nickel cadmium batteries. Next is lithium ion batteries. Lithium ion batteries are very small in size and lightweight, generally used in smartphones and the electrical gadgets. So they are very small in size and lightweight compared to nickel cadmium and nickel metal hydride and lead acid batteries. Normally full charge, normally lithium ion batteries can be fully charged within 60 minutes by using a special charger, and they have a very long life compared to nickel cadmium and lead acid batteries, with full capacity of around 1000 charge cycles, and they need very low maintenance as well. The next type of batteries is lithium polymer batteries. So lithium polymer batteries are industry standard batteries, and they are very small in size, very small in size and weight compared to nickel cadmium and nickel metal hydride and lead acid batteries. They can fully charge in 180 minutes with a special charger, and long life will full capacity up to 1000 charge cycles. They need very low maintenance. And an example of battery given over here is like 3 into LiPo 4.2 2200 milliamp milliampere hour cells are given, which con combined weight gives as 192 grams, and discharge current is 20 to 2200 milliampere hour, that is 44 ampere hour. So this is all about the batteries, and based on the requirement you can use any of the batteries that is required. So stay tuned for next coming videos, and we'll discuss more about robotic components, working mechanism, and do some hands-on session on using these components in coming session. Stay tuned. Thank you for watching this video.